Today we will start the second part of tree. In the last class, we discussed a brief overview on nonlinear data structure, that is tree. So today we will continue with that discussion. I told you that tree is very important for this subject and also for your exam. You're supposed to get a lot of questions from tree, the theoretical questions, and it's quite easy to understand. No intelligence is required. If you know the technique, you can answer a lot of questions. Right? So we will continue with binary tree. So let's start presenting. How many of you have joined? Let me see. Okay. Let me start presenting. The screen is visible to all of you?
Yes, sir.
Visible?
Yes, sir. Visible.
So we discussed about this tree, what is the usefulness of tree to develop a real life project in the light of database management system. We discussed all this in earlier class. Today we will start discussing whenever we need to search a particular record in a tree, from a tree, whenever we need to search a particular record, right? So we have to traverse, like in a linear data structure in English. What we used to do, uh, we had to start from the root, and the moment we find the particular key, we stop traversing. Right? And if we don't find, we have to search the entire list. This way, we have to start from the root. I discussed the structure of a tree, uh, it how it is formed. So to search a particular node in a tree, we have to use some techniques to add a node or record after a certain node in tree. We have to reach at that node from where the new node will be added. The child node will be appended. So for that also we have to reach to that node. Always we have to start searching. We have to start traversing from the root. So since it is a non-linear data structure, there are some specific techniques maintaining which we can traverse a tree. Mainly, there are three types of techniques. One is in order, another is pre-order, and the third one is post-order. Let's discuss all these techniques one by one. Okay. Could you see the screen?
Yes, sir.
So data structure and algorithm, three traverse, right? In order, pre-order, post-order. These three techniques we are just talking about. In order traversing. So after traversing all the nodes, you will get a sequence, and that is called the in-order sequence, which comes out if you follow the technique of in-order traversal, right? So if a binary tree traverses in order, the output will produce sorted key values in an ascending order. This we will test later. There are three techniques for traversal. I want to I want you to put it in mind that this is very important for your exam and very easy. At least one question you will get from this one of the traversal techniques, right? So you should study these three techniques properly. Okay? So in order traversal, I will discuss the technique. This is the root of the tree to discuss. This is the left subtree and right subtree. I repeat that left and right means not the left side or right side of the picture. It is the left side of yourself and right side of yourself. Okay, don't get confused. So many students generally get confused. They consider the left side of the picture. Okay, the left means your left side, right means your right side. Okay, so left subtree and right subtree. Why it is subtree? Because it is also a sub part of a tree. That's why it's subtree. For this subtree, this is the root. But for this entire tree as a whole, only one root is there. This is the root. And you know, binary tree, at most two nodes can be connected with a single node, which we consider as a root node, or the nodes which came out from the this parent node are called the child nodes, right? So B and C are the child nodes of this A node. A is the parent node of BC, and as well as A is the root node of this entire tree. Here B is not the root node of the entire tree, but B is the root node of this left subtree. Or B is the parent node of the D and E. Likewise, C is the parent node of F and G, right? So technique is, don't waste your time. You will you will read this later, but you just listen to me carefully. Okay, how you will traverse the in order way, right? In order way, the technique is always you will move maintaining this order: left, root, right. First left part you have to traverse, then root, then right. And always you have to start traversing from the root. So first when you start traversing in the in order way, you will get this one root, no, discard it. You have to come to the left side. So left side is here. Then again you got a node. You have to check whether it is the leftmost of the tree. No, it is not the leftmost. There is one node still present in the left side of this node. So traverse left. Now there is no node. So for this subtree, if you maintain this sequence, left, root, right. So it is the leftmost part. So D will come first. So you have to pick the value D, then left, root, right. Then after D, B will come, because for this subtree, this is the root. Then E, left, root, right, E. Now left side completed. Now left subtree is completed. Okay. After you complete the left part, left subtree, what I told, left, root, right, then root means E. So first D, B, E. After you get this sequence, after you traverse this, then you will go to the root part. Left, root, right, root means after E, A will come. Okay, left part is completed, root is completed, then come for the right part. Now when you are coming for the right part, you have to check that whether you have reached to the rightmost part. It is the right part and rightmost part. No other nodes are connected after this level. So this is the rightmost part. So for this you got C, but discard C, because for this subtree you have to reach to the leftmost part. So this is the leftmost part. So left. So after A, F will come left, and for this subtree after F, left root C will come. So F, C, then right G. You can see in each and every subtree there is a label. I have marked as label according to the sequence 1, 2, 3 for this one, for this one, for this left part. If we consider this tree as a three parts, left subtree 1, root 2, and right subtree as 3, and again if you consider this subtree as a tree, then this is 1, 2, 3, 1, 2, 3. For this tree 1, 2, 3. 1, 2, this means this sequence, left, root, right. Left is completed, then root 2, then right. When you come right, you have to again maintain the same sequence 1, 2, 3, left, root, right. So first D, if you are supposed to print, if you are supposed to write the sequence of this in order technique, what you write, D, B, E, then A, then F, C, G. Just check it out. D, B, E, D, B, E. I repeat, the technique is, this is for the inner traversal. Technique is the sequence is left, root, right. First complete the leftmost part, then root, then right. This is the leaf node, so no more node is generated from this. So this is the leftmost part of this subtree. So left, it's ended here. Left, root, right. So start searching from root. After you after you get the root, you have to, I repeat, you have to traverse to the leftmost part. You are coming here. For this, then you are coming here, leftmost part, but no more node is generated. So this is the leftmost node. So for this subtree, left, root, right. So first for this subtree, enter tree, the D, this key will come first, D. Then for this subtree, D, B, root. Then right, D, B, E, D, B, E. Then root will come, A. Then for left part is completed, root is completed, then right part. For this right subtree, again you go to the leftmost node. This is the leftmost node. So after A, F will be printed. After A, F is coming. Then root, then C, then G, F, C, G. Got it? Hello.
Yes, sir.
I repeat. This is very important. Without studying tree, you will not qualify in this subject in the semester exam also. It is very easy. No intelligence is required. I repeat, no intelligence is required. I am discussing only the theoretical part. You don't have to write. You will not. You are not going to get any question where you will be asked to write code for that. Still, if the time permits, I will show you the code for this insertion or making of a tree, like we discussed the making of a linked list, though it was not included in the syllabus, right? Anyways, so we are discussing the three kinds of traversal technique. We have discussed the in-order traversal. In in-order traversal, the sequence will be left, then root, then right. left, root, right. Got it? So maintaining this sequence, we are actually traversing a tree in order way. Got it? Any question? Then I will proceed for the second technique.
স্যার বুঝেছি স্যার।
Understood? All of you have understood? Or should I repeat? Or you have understood?
আন্ডারস্টুড স্যার।
Okay, so
Understood, sir.
let me proceed for the second technique. Right. See, the algorithm is very, very easy for this, traversal. What is it in here? Until all nodes are traversed, recursively traverse left sub. This recursively means repetitively, right? Repetitive manner. If a function is called repetitively, the function calls itself. यहाँ पे फंक्शन अपने आप को कल करेगा. रिकर्सिव इज अ स्पेशल टेक्निक ऑफ अ फंक्शन, स्पेशल काइंड ऑफ फंक्शन वेयर a particular function will call itself, and definitely there must be a condition from where this calling will be stopped, otherwise the program will get an infinite loop. Fine. So recursively means repetitively traverse left subtree, then visit root node, then recursively traverse right subtree. So left, root, right. Very easy, these three steps. Very brief algorithm, right? It's very easy to keep in mind. Okay. Now pre-order traversal. The next technique, pre-order traversal. Pre-order traversal, what happens? First we consider the root. When it is very easy to remember, pre means root will come first. Pre, in order, pre-order, post-order. Here pre means root will come first, and in post-order root will come last, right? So let's discuss regarding pre-order. Pre means root will come first, right? So the sequence will be root, left, right. What was the sequence in order? Left, root, right. Here the sequence will be root, left, right. That's why you can see 1, 2, 3. Here it was there 1, 2, 3. 1 was the left part, then root was having the second level, and the right part was having the third level. But here root, left, right. Root is having the level 1. So first you have to pick the key value of the root node, right? So you are starting from the root and you are taking the value root. So you will come first root, then left part you have to traverse, right? Then left part you are coming. Whenever you are encountering this B, you are checking that this is the root of this subtree. So take the value B, 1. Then come here, it is no more generated from this, so this is the leftmost. So root, left, right. So then left will have to consider. Then after B, D will come. Then right, E. So A, B, D, E. Root and left part is completed. A, B, D, E. A, B, D, E. Okay. So root is completed, left part is completed, then come for the right subtree. After you come the right side, right subtree, check. This is the rightmost subtree, so C has to be considered. C, and then
May start
because no more node is generated after this level. So this is the leftmost node of this subtree. So root, left, right. So after C, F will come, then G. So entire sequence will be what? A, B, D, E. Then C, A, G.
Visible or
A,
not.
B, D, E, C, A, G. Got it? Very easy.
Yes, sir.
So what the difference between the in order and pre-order? Then in order, first leftmost we have to consider, then root, then right. Pre-order, first we are considering the root, then left, then right. Okay. Got it? Very easy. Algorithm is just like that.
Just like the code for the
in order, Visit the root node.
full
Here we told
implementation
visit the
using
recursively traverse the
linguist,
left
right?
subtree.
So we
Here
discussed
and
NQ,
visit
that
the
is
node
adding an
was
element to
in the
the
second
queue
step.
and
But
display.
here it
And I
will
also
come the
asked you,
first step.
you
Visit
will
the
just
root
change
node,
a
then
display pattern
recursively
update,
traverse
that
the
is
left
the
subtree, then
front and
recursively
rear will
traverse the
be
right subtree.
written.
Right.
How many of you have done this?
So recursive,
Hello.
this is, I will
How many of you have
take an
done this?
entire class on
I
this
told
recursive
you
function data structure.
to
Recursive
write
is
a
very, very
program just
important in
to change the
the subject.
display
I will
function update so
discuss
that
the
the
different
font
characteristics
comes
and how
before
we
the first
write a
element
function
of the queue
in
and
recursive
rear
way.
come
That we will take
after the
different
last
classes on this,
element
right?
of the
On this
queue.
subject.
Okay,
Recursively means by this
got it?
time you
স্যার
just
একবারে ডিসপ্লের
the time
জায়গাটা
you consider
দেখাবেন, মানে আমি
recursive means
অ্যাকচুয়ালি সিঙ্গেল
repetitive way,
লিংক
right?
লিস্ট ওটা করেছিলাম, আমি কিউ এর এতে
Falling in
ইমপ্লিমেন্ট
repetitive
করিনি ওটা।
nature, in repetitive pattern, right? So visit
আমি
the root
এটা
node,
বলছিলাম
recursively traverse
because
the left subtree,
let me
recursively
run
traverse the
it.
right subtree. Got it?
Okay,
So your traversal is completed,
let me run
your
this
traversal is
one.
completed.
না স্যার,
So all
অ্যাকচুয়ালি
of
যে
you
while
understood
লুপটা রয়েছে
your
না, ওটার
traversal.
একটা আগে ওই প্রিন্টে ফ্রন্ট
Yes, sir.
অ্যারো বলে করলে ওটা স্টার্ট হবে,
Okay,
আর
so in order
লুপটা
is
শেষ হওয়ার
completed,
পরে একটা
reorder is
প্রিন্টে যদি আমি
completed, and then
এন্ড বা নাল
post order.
ওরকম কিছু দিই
What
তো ওটা
you will
একটা
get a
প্রিন্ট
question,
হয়ে
you will,
যাবে।
What I
if
want
you
is this.
go to the
This
previous questions of
that
Macau,
is
you will
only
get that here you have
then
given a tree is your diagram you will get, and from this diagram the question will come.
42.
Write down
This I
in
want that
order,
front
reorder,
comes here
and
after
post order sequence
FORNT,
for
then an
this.
arrow,
So
and
this
rear.
is
Then after
what
this arrow, rear will
you
come,
have to
and
write
this
this.
arrow will
Okay.
be
So if
towards
you
50.
don't understand,
This one
definitely
I
you are going
want.
to make
So
wrong.
I want
Okay.
all of you
Anyways, so
send me the code,
the
right,
screen is
by this
the screen is
Saturday.
visible, na?
Okay.
Yes, sir.
Actually, I expected that you will
Sometimes what happens if
send the
somebody
code, but since
tells
I didn't
in
post
one
any
class it
assignment
happened
for the
that
this,
I didn't
so
get
by
the
yourself didn't
presentation
send
on
any
recording, right? If
of
that
this, right?
happens, you will
I
just
wanted,
prompt me. Okay,
I want all of
you'll
you
give a
to
prompt.
send
That's
this
why it is
one,
not coming.
okay?
Okay,
But it's
Okay.
Saturday.
okay, and
So
স্যার
so
মানে এই
pre-order and
নোটস
then
গুলো
post
তো
order.
ক্লাসরুমে
Post
নেই,
order
মানে
I
স্যার এই
explained. It is
কোডটা
the
কি
last
আমরা
technique in this
নিজেরাই
traversal.
লিখে নেবো, লিঙ্ক
Here,
লিস্টটা
what
চেঞ্জ
will
করে
happen?
জাস্ট?
কোড তো আমি দিয়ে
First
দিয়েছি, এটাই তো
left,
কোড,
then
এটাই তো
right,
কোড,
then
ভিডিও
root.
ফলো করলেই
So
তো কোড
post
পাওয়া
order,
যাবে।
I told you that
মানে
in post
ভিডিও
order
you
root
will
will come last.
হ্যাঁ
So
go to the
left,
video, you
right,
will just
root.
follow my
Left, right,
ওকে।
root. This
this is
three
what
sequence
happens
you have
that
to generally keep in
I
mind. For in order,
uh, means
left,
can notice one thing that
root,
you
right.
don't
For in order.
follow the video of the
Pre-order root
of the
will come
rules.
first. Root,
You have to
left,
listen.
right.
It's
For post
maybe
order,
that it is means
left,
constantly for
right,
the entire
root will
session.
come
It may
last,
be
right?
difficult for
So
you to
one, two, three,
concentrate
right?
all the
For
session. Right? You
this
may miss one or
subtree,
two. You may miss some
one,
minutes.
two, three,
You may miss some
okay.
topics or
For this
points
subtree,
for some moments. So I
one,
expect all
then
of you
one,
to
two, three.
visit to watch the video
For
again.
this subtree,
And if you follow the video, so
one, two,
just
three. Okay. So starting
with the
from the
pause
root, we will
after 2 minutes or
discard,
3
right?
minutes,
We will not
check
pick
the, if you
root
follow the
first.
code,
First,
you
we have
will
to pick
understand.
the
So I want
leftmost.
all of you
Come
to
here
do
in the left side of this root.
video and
Yes, we have
follow
come
the
here.
code.
So is it the
Everything is
leftmost?
explained in
No.
the video, no?
There is
There is
another
code,
child
isn't
node.
it?
Come out from this
ইয়েস,
root node.
ইয়েস
This
স্যার। না
is
স্যার,
the
আমি অ্যাকচুয়ালি
leftmost
বলছিলাম,
node.
মানে আমি লিঙ্ক
So pick
লিস্টের যে
this value
কোডটা
D.
দিয়েছিলেন না,
So
ওটাকে আমি
D
জাস্ট
will
মানে
come
ওটা
first.
মডিফাই
Then
করে
for
ওটা
this
জাস্ট আমি
subtree, this
ইমপ্লিমেন্টেশন
is
অফ
the
কিউ
right
এর
side.
এতে
So
চেঞ্জ
D,
করে নিয়েছি, ওটাই
you will
বলছিলাম।
come after
যেটা
that
খুশি করতে পারো,
left,
বাট আমি তোমার জন্য
right,
বলছি,
then root.
তোমার জন্য
Then
বলছি যাদের কোনো যদি
so D,
কনফিউশন থাকে,
E, B. D,
অনেকে আছে যে
E,
বুঝতো
B.
না, আমি I have
Left part
seen
is
that
completed. Then
many of you
no
may
root.
not
Root
understand
is there, but
my
discard this
lecture
because
because you
left,
are weak in
right,
C.
then root.
Maybe
Come to the right
especially
part
for
of
the
this subtree.
concerned about the
Right subtree. After you
students from
come
the
here,
lateral
you are checking
entry.
for this
So
subtree.
they
This is the root, so
may not
discard it.
that much
You have
strong
to
in C, the
go to the
fundamental of C.
leftmost node.
So
So this is the
if they
leftmost
follow the
node of the
class and didn't
subtree.
understand
So
anything,
pick
they
this
immediately
value
they
F.
will be worried, so I don't
So
getting understand.
B,
So you, what
E,
you have to
B.
do,
After
you have
B,
to
F will come.
follow my
After B,
video
F will come.
again and
Then
again.
left
And you
and
know, in
corresponding
my
right
YouTube
node
channel,
of this
there
left
are
is
so
this
many classes
G.
on C
So after
also.
F,
Isn't it,
G will
Sayantan?
come. G.
In the last
Then
year,
root. So
Yes,
A,
sir.
B, C, A,
on each
B,
and
C. So
every
left is
chapter,
completed, right part is completed, and underneath is left.
your
At last you'll
structure,
write
array.
A.
So
Got
you
it?
will get a lot of video
Okay.
lectures. So if
Understood?
you
Very
follow that,
easy.
you just if you go to
Left,
my channel,
right,
you will
root.
get a lot of
Okay.
lectures. I think more
The
than
algorithm
50 or
is
60
like that.
lectures are
All the
there.
algorithms.
All these
Until all
structures,
nodes are
linear,
traversed,
quadratic. So all
recursively traverse the left
so
subtree.
many subjects are also
Then
there, but
recursively
you will
traverse
get
the
to
right
know that
subtree.
what is the lecture
Then
for.
visit
In
the
each and
root.
every video
Okay.
description, I
Very
write
easy.
this. That what is the
Now,
video for?
one most
Okay, so if you
important
uh,
uh,
go through that description, video
thing
description,
I'm
you
going to
will understand.
discuss
Or if you
from
search
this
my
binary
name,
search tree,
if you search
you
my
will
name
get a
in
question. You
YouTube
will
or
definitely
in
get a question. In
YouTube,
every
you will
year,
get the
a
link
question
full
has
of it,
come
right?
from this
With the
subtopic what I'm going to discuss.
substring
But before
like
that, you
an
can just the
Professor
difference
K.Basu
between binary tree and
lecture
binary
on
search tree. In
lecture
the
on
last
function,
class,
or
I
the lectures
discussed
on
a
C,
lot on
right?
this.
C programming.
Binary
If you
search
search
tree
that,
is
you
a
will go more
special type of
optimized
binary
search tree,
tree
right?
where
Anyway, so I
the
expect all
tree
of you
is
to
having a
submit the code,
special
right?
property. What
After
is
you
that
execute in
property? In
at
binary
your home,
search
you
tree,
submit the code.
all the left nodes
So let us
have the less
discuss
value
the remaining
than
part.
its parent node,
Right.
and all the
Yes.
right nodes
So this is the
have
DQ.
the
This
greater
DQ
or
means
equal value
deletion
than
of
its parent node. This is
an
the
element from a
property we
group, right?
discussed in the last class,
So
isn't it,
why
Samorendu?
Yes, sir.
So this is the binary search tree is a special type
here
of binary tree with this property. So
it will
in
be a bit
one
different
sentence I
from
can
the
write this
linked
property.
list,
This is
deletion
left
of a node
subtree
from a linked
is
list, because
key.
in deletion
Key means
of a
the
node
node
from a
values,
linked
right?
list, what I
We have to
did,
consider the value.
I
Now otherwise how we will compare which
wrote
one is
a
greater, which one is
generic
better, right?
function,
So key
okay,
values of left
from any
subtree
position,
less
from
than
any
node
position,
key means
the
here it is
node
root
will be
node key,
deleted
and
if
key
the
value of
node
right
is
straight less
present
than
in the
equal
list.
to key value of right
That's
straight.
why to
In
make it
one
generate,
this logical statement you can
I
write
my
this way.
program
Okay.
was
Okay.
having the liberty
Now
for the
presentation is
user.
this. We discuss this. The,
User
all
name is
the
what node
nodes in
he
the
or she
left
wants
side
to
of this
delete. Means
root
he or she will give an integer
have the
data
less
part
value.
information,
14 is less
and the
than
node
27.
containing that
For this
data
subtree 10 is
will
less
be
than
deleted
14.
from the
But
list.
19
That was
is
a
the left
quite
side
generic
of
function.
27. So 19 will
If
be the
anybody can
least, that's why
understand
least.
that
But
generic
right
delete
side of the
function
14,
in my
so
linked
this
list,
value will be greater
so
than
he
14.
or she
Okay.
can
So it is maintaining
delete
the
any
property
node
of the
from any
binary search tree
position. Maybe the
perfectly.
question you may
Okay.
come
All the
get more
nodes
optimal.
which have
Delete the
the
first
right
node. You
side of
can,
this
if you
subtree
understand the
will
entire
have the
code for the
greater
deletion,
value,
generic function, that generic function, what you
greater
get
than
in
27.
linked list,
All
you
the
can
nodes,
delete
see
the from
35 is
first
greater
node.
than 27,
If you
31 is
ask
greater
the
than
delete the last
27,
node, you can delete.
42 is greater than
If
27.
it is
But here, for this
explicitly
subtree,
specified,
this will
then delete
less
the
value,
third position.
this will have less value.
Delete the fourth
31
position.
is
You can
less
also
than
delete, right?
35. This must be
So here there is no scope.
greater value than
Otherwise,
35. So
if
42 is greater
if
than
that
35.
happens, it will
Right.
violate
So this
the
is a perfect
principle of
binary
Q,
search tree
that is
maintaining
first
its
in,
property.
first
Right.
out.
Okay.
So always
So these are the basic
here
operations we have already
specific
discussed how to insert,
deletion
how
from
to
a
search.
specific
You know,
position
insert
is
in
there.
you have to,
What will be
whenever
that
you will
position?
insert a node
On the
in
queue,
BS tree, you will
if you
maintain this,
follow
right?
that
If you
first
get
in,
a
first out,
less value, then
what
that you will
node
come in the
we
left
must
side. If
delete
you
from the
get the
queue?
right,
What from what
key
position?
value, that will come
Tell
to the
me,
right part,
from
right?
what position
So
I
in
will
order
delete?
to get a posture, I discussed, and this is the just like the linked list
Are
node.
you
This is
getting my
a
question?
simple node structure.
Hello.
What was there in our
স্যার
linked list?
আরেকবার
Only
করবেন একটু
one
আটকে গেল
pointer was there. That was
বলছি
our
এখানে
next, right? But here, since one node is
here
having two pointers,
in
one is left
DQ
and right,
means
so
deletion
two
of an element
pointers will
in
be
Q.
there. Struct node
There
star
will be a
left child,
particular
struct node star
position
right
from
child,
where I
and this
have
is for the
to
data,
delete the
right?
node. Program
Just a
will delete
simple
the node.
modification of
It
our
will not
linked
be
list
generic.
node structure, right?
From any
Now
position you
there is an
can't delete the
example.
node,
I actually
because it will
forgot
violate
to
the principle of
write
FIFO
the question.
or the principle
Here
of
there will be a
Q.
question. When I
So
will be
from a
supplying this
particular
material to you,
position
I
node
will
will be
put the
deleted
question over here,
in
right?
DQ.
The question will
What is that
be
particular position?
that
and
make a
Hmm?
tree, make a binary search tree
Exactly.
from
From,
these two
so
techniques.
always we
In
have
order
to
traversal and pure
delete from
traversal
the
means You will be given
first
these
position
these
front.
two traversal
While in
sequence
Q,
in the
what we
question.
did,
And the question
we
will come
always
that make a
add and
binary
we look
search
at the
tree
end,
from these
add at
two
the end, right? So that
traversals. Okay, got it. So up to this part you will get in your question. Question will be make a binary search tree with the following, right? The following means this your traversal will be given and your traversal. How to do that? This is very important question. Okay, all of you are concentrating. All of you are concentrating. I repeat, all of you concentrate on the discussion. You are going to get definitely a question from this. Okay, all
Okay,
of
sir.
you are getting, huh?
Okay, sir.
The question is make a binary search tree from this in order and pre-order traversal technique. What is the way? The way is first you just traverse the pre-order. You just read out the pre-order traversal. You know from this pre-order traversal what I meant. Root will come first, right? So the process is that pick pick the key one after another, pick the key from or pick the node from pre-order and place it on your diagram for binary search tree and check the value of the node following the root node. Means you just listen here pre-order in our traversal. I will pick this one from the pre-order. Since the pre-order starts from the root node, so definitely without considering anything, you will just put this one as a root node of the binary search tree you are going to make, right? You are going to draw. So one will come. Then again, next after one in pre-order traversal 2. So pick the value 2 and compare and check and examine that what is the position of 2 from 1 in comparison to 1 in order traversal. The technique is pick the value from the pre-order traversal and check its position from the in-order traversal technique. I repeat, pick the keynotes, pick the nodes from the pre-order sequence and check its position in the in-order sequence. So 2, here check the position of 2 in order. 2 comes the left side of 1. So straight away you will write this. 2 will come here, right? Got it? This is actually where
Yes, sir.
draw the binary tree, not the binary search tree. I repeat, it is the binary tree. Okay, means the sequence you will be giving, you have been given with maintaining that sequence. You have to draw the tree, whether it comes out with the binary search tree or binary tree, it doesn't matter. You have to maintain the sequence. You have to maintain the rule, and you are supposed to draw the tree. Whether tree becomes the binary search tree after you draw the diagram, that doesn't matter. That is not your lookout, right? See the 2, if I consider the 2 as a key value, na, so definitely the 2 will not be the greater than 1, right? So it violates the binary search tree. So don't bother about this. Maybe you can say that 2 is not a key value. 2 is just an what to say, any level of the tree, right? Binary search. So I repeat, the technique is pick the node from the pre-order and check its position in in-order sequence. So in order sequence, the position of the 2 comes the left side of the 1. Okay, so you will place it on the left side. Then after 2, 4 will come, right? So check the position of 4 in order. It is coming on the left side of 1 and left side of the 2 as well. So 2, left side of the 1 and left side of the 2, 2, 4 comes. Then 3. Then consider the 3, right? Pick the value 3, you have to place it in the binary tree. So where you will place, check the position of 3 in order sequence. It is just right side of the 1, 3, right side of the 1, right? So 3 will come right side of the 1, 3 has come here. Got it? Then pick 5. Check the position of the 5 in comparison of this one in your traversal. Alright? So 5 comes after what? 5 is in the right side of the 1. Okay, but left side of the 3 is 5, where the position of the 5 is right side of the 1, so it will go somewhere on the right side of 1, definitely right of the 1. But in the right side, you are checking, you can see that already a node is placed. So now it is in the left side of the 3 or as well in either sequence. So 5 will come here. Now 7. Check the position of the 7. 7 comes at the right side of the 1 in order sequence. So right side of the 1, but left side of the 5. Left side of the 5. So right side of 1 and left side of the 5 here. Okay. After that, 8. 8 comes. So 8 comes right side of the 1, right side of the 5, but left side of the 3, left side of the right side of the 1, left side of the 3, left side of the 3, but right side of the 5. Right? Got it? You will check one by one level by one level. If you check, when you will place, when you are going to place this 8, you can say this 8 comes the right side of the 1 in your sequence. So you are coming the right side, you can see there is another value 3. So you have to check the 3 where 3. But 8 is the left side of the 3. So left side you have to follow, left branch you have to follow. Now after following the left branch, you can see that there is another node, 5 is already placed. So now check the position of the 5. Now you can see 8 is exactly on the right side of the 8, right side of the 5. So you just place it on the right side of the 5. Got it? Now 6 is left. 6. So 6 is on the right side of the 1, right side of the 1, and 3, and right side of the 3 as well. So just put it here. Got it? So this is the way we can design a binary tree from these two traversal technique, inner traversal and periodic traversal. With the help of only one traversal technique, we can never draw a binary tree. We have to get the two traversal techniques in order period. Okay, got it?
Yes, sir.
Any question? Any question?
No, sir.
So we will conclude this discussion with this, right? So today we have learned the traversal technique, three traversal technique in order period, and then we have learned very important that from the two traversal technique in order and pre-order, we can construct a binary tree. Got it? Okay, so it's clear.
Yes, sir. Yes,
So
sir.
definitely, till now, I have to decide whether this week or not. If I can make it, can manage it to revise the question. So definitely, I will take online test in this week. Otherwise, it may be extended for the next week. Okay, so you start preparing yourself for this subject, and it will be a preparation also for your coming exam, MAFA exam. Okay, so okay.
Okay, sir. Thank you, sir.
Uh,
Thank you, sir.
Thank you, sir.
Thank you, sir.